Hello. In this video, I'm going to show how to solve the Mary Ellen Carter problem. Okay, so the Mary Ellen Carter problem is that you have a ship that's on the seafloor. So here's the seafloor. Here's our ship known as the Mary Ellen Carter. And it's under the waves, so we'll put the surface up here, and that is a distance d. We are going to assume the ship has a volume v, the water has a density rho. We know what the density of water is. This is in the sea, so the density of water is about 1.03 grams per cubic centimeter. It's 0.03 because salt water is just a little more dense than fresh water. Okay, so it has a mass m, volume v. We need to lift it at distance d. And the first question is, one, how much work must be done to lift the ship from the ocean floor to the surface? Okay, so what we're going to do is we're going to lift it. We've got a barge up here, and it's going to have a crane. The crane is going to be down attached to our sunken ship, and we're going to lift the ship up. Okay, so let's see here. Why don't we start with a free body diagram? It's a good place to start a problem. What are our forces on the Mary Ellen Carter? Okay, so we have a force up. That's the tension from the crane. We have downward, we have mg. We'll have a normal force while it's sitting on the seafloor, but as soon as we're starting to lift it, there's no more normal force because it's not on the seafloor anymore. It'll be held up higher. But there is a buoyancy force, forced buoyancy. Okay, so we're looking for how much work. So the work is being done by the tension. So first I'm going to find the tension. Tension is going to equal mg minus force buoyancy. This comes from the fact that if it's going up slowly, so acceleration of 0, then tension plus Fb minus mg equals 0, and I've solved for tension. Okay, so tension is the mg, the force of gravity, minus the buoyancy force. What is buoyancy force? Well, we can replace buoyancy force with the volume of the ship times the density of water. Times g. So that's buoyancy force. Rho vg, where it's rho of the water, not of the ship. It's rho of the water. Okay, and it's basically making this is the amount that the Mary Ellen Carter floats. Okay, so that's tension. To get work, we need to do work is force times distance, delta x. Our force in this case is tension. Our distance is d. So our work is d times our tension, which is mg minus v rho g. And simplify that just a bit. I can pull out a g, so I can write this as dg m minus v rho. And that is how you find the work needed to lift it. Now, it's not only do you want to know the work needed to lift it, you also might want to know the power. How much power does the winch basically in the crane need to put out? In other words, how quickly does it need to do work in order to lift the Mary Ellen Carter at speed v? So that's question number 2. Okay, so the first way I'm going to solve this is by power is equal to work over time, or something, time. Okay, how long will it take to lift it? Well, if we're lifting at a distance d, distance is equal to, or well, let me write it this way. Velocity is equal to distance d over time t. That's what velocity is. It's distance per time. If we want to know time is equal to distance over velocity. So we can plug that in over here, and we get the power is equal to the work over the distance over the velocity. You can rearrange that. Velocity is in the denominator of the denominator, so that makes it in the numerator. So it's power is equal to velocity times work over distance. I can plug in the work I have from up here into here, and I get power is equal to, okay, if I plug that in, the D's will cancel, and I'll get VGM minus capital V rho. So this is a capital V, which is different than the little v. Okay, next let's do this. So this is solution method A. I'm actually going to show you two solution methods, so this will be solution method B. Solution method B is that power is equal to force times velocity. In this case, our force, we already worked it out. Force is G M minus V rho. That's the capital V. And we can multiply that by velocity to get power. So that's two different ways of solving for power. So that is the amount of work and the amount of power. And I guess up here we have also solved for the amount of force needed to raise the Mary Ellen Carter, that her name might not be lost to the knowledge of men, and to those that knew her best, and were with her till the end. Make the Mary Ellen Carter rise again. Okay, so my singing sucks, but whatever.